Hey there! In this video we are going to look at solving exponential equations using logarithms. You may have seen an earlier video of mine that introduces what an exponential equation is and how you can solve some of them using the concept of related bases. This method of using logarithms is going to allow you to solve any exponential equation regardless of whether the bases are related or not. Alright, we're going to start with a fairly simple looking equation here, 2 to the x equals 43. Although it's worth recognizing that that one has bases that are not related. Those two values aren't powers of the same number, which is why we're going to use this approach of using logarithms to solve it here. Before we do, we're going to take a minute to just estimate what the solution is, just because it's important to remember what we're actually doing when we're solving an equation. We're looking for what value of that variable makes it a true statement. Now, you maybe can think about powers of 2 that you know, and ones that are close to that, particularly if we can think of one above and below. So you probably know that 2 to the 5 is 32, and 2 to the 6 is 64, and since 43 is between those two numbers, then the value we're looking for here has to be between 5 and 6. So, I don't know, 5.5, you can maybe guess because it's kind of partway in between there, but we'll see as we work through. We're going to use two different methods here. One is using base 2 logarithms, one is using base 10 logarithms. Using base 2 logarithms, it's actually pretty quick and easy to get the solution. That is, if you have a calculator that has base 2 logarithms on it. The general approach that we're going to do here is, if we want to get at the variable that's in the exponent within an exponential expression, we're going to do that by taking the logarithm of both sides. And in this case, we're going to use base 2 logarithms. So basically, if that's equal, then if I take the logarithm of both sides, logarithm of 2 to the x, that should be the same then as logarithm of 43. Now I said I'm going to do base 2 in this case, and the reason for that is because then these two things right here, log base 2 of 2 to the x, those are inverses, and those cancel out, and then all I have is just an x over here, and x is the log base 2 of 43. Essentially, you're taking this exponential expression and you're writing it in logarithmic form using base 2. In a second, we'll go to a calculator and get that value to get an approximate decimal value for that. But first, we'll use this approach, and you'll see it's actually not too much more difficult. Now, you might say, why are you using base 10 logarithms if this is base 2? Well, because lots of times calculators don't have other base logarithms other than base 10, because really you don't need them, as you'll see here. We're going to do the same thing, except we're going to take the log base 10 of both sides. So we're going to say log base 10 of 2 to the x is equal to log base 10 of 43. Now, this doesn't cancel each other out over here because it's not the same, log base 10 of 2 to the power of. But what you can do is you can use the power rule, and this exponent can go in front, and we can write it as x times log 2 equals log 43. And then what you actually have is you have the variable that you're looking for times a number. Log 2 is just a number. It doesn't involve a variable anymore, and that equals another number. And to isolate that variable, we can divide both sides by log of 2. You can write it down if you want, or you don't need to write it down certainly, because then this cancels, of course, and you end up with x is equal to log 43 divided by log of 2. Now, as we said, we're going to go to the calculator and get what that value is right now. All right, we'll check this one first. This calculator has a log any base button, so log base 2 of 43. It's going to give us that value, and then we'll check the other one. I'm going to use this fraction expression and put log 43 on top like that, and then log 2 on the bottom, and you get the same thing, right? Same solution. If you don't have a fraction expression on your calculator, you can still, of course, do it just by saying log 43 divided by, as long as you close that bracket, log 2, you'll get the same thing. All right, so we have approximately 5.426 or so in either case, right? I'm going to say approximately, right? This is an exact value, but what I'm writing now is an approximate. So I'm saying equals, approximately equals there, because I want to be kind of proper about what I'm doing here. 5.426. Now you might be thinking at this point, why on earth would you do it this way when this looks so much simpler and quicker? Well, there's a few reasons for that. For one, you'll see that some of the later examples we do are exponential equations that have more than one exponential expression in them. This one only has one and involves base 2. So since there's only one, we can just use base 2 to right away cancel it out like we did here. Well, when there's more than one and the bases are different, that's not going to work. And then number 2 is maybe you just don't happen to have a calculator that can evaluate those kind of things. So a few reasons there. So go with it, have a look at both methods, and appreciate both methods as we move forward. All right, let's try one more here. Now this has a lot more involved than the first one that we did, but it still has our variable in one place here, and we're going to work by isolating that. It's just that there's a few things we have to do before we start to work with our exponential expression. There's also a multiply by 5 and a subtract 500 here. We're going to deal with those first. We're still going to use two different approaches here, base 3 logarithms because that's the base for the exponential expression, and base 10 logarithms because that's a common approach that people use. So that equation up there, 5 times 3 to the 2x plus 1 minus 500 equals 2500. The first thing we're going to do is, just like any expression, just like any equation, if you have 5 times this thing, minus 500 is 2500, we are going to get rid of this 500 first. If I add 500 to both sides, or in other words, if I think about moving that term to the other side, I'm going to end up with 5 times 3 to the 2x plus 1 equals 3000. I have 3000 over there. Now, next you might be tempted to do something with those two things and multiply them out. That's a common mistake, common wrong thing people do when they're solving this, but you have to remember that this exponent only applies to that base, not to the whole thing. So writing it as 15 to the power of something isn't going to be equivalent to that. But what you can do is you can divide both sides by 5 again. I'm not going to leave that written there because we know what we're doing there. We're dividing by 5, which just would leave 3 to the 2x plus 1 here. And if I divide the other side by 5, I'm going to get 600. Now we have an exponential expression and another number on the other side. So now is where we're going to use logarithms to get at that exponent. So we're going to take the logarithm base 3 of this side. And the reason is because those are going to cancel out. Logarithm base 3 of 3 to the power of something, those are going to cancel out. And of course, then I got to do the same thing on the other side. Log base 3 of 600. So then on the left, all I have is 2x plus 1 equals, on the other side, log base 3 of 600. And then I can isolate it just like any other equation. 2x plus 1 equals a number. This is just a number. We can subtract 1 from both sides, and we will have 2x equals log base 3 of 600 minus 1. And then we can divide by 2 on both sides, and we'll have log base 3 of 600 minus 1, that whole thing divided by 2. And we'll go to the calculator in a minute to see what that is. But first we'll use our other method, which is going to be using base 10 logarithms. The steps up to this point are exactly the same. So we're going to start in with it partway through at 3 to the 2x plus 1, and that's equal to 600. Now for this, we're not going to use base 3 logarithms, we're going to use base 10 logarithms, so we're just going to take the base 10 common log of both sides. And again, that doesn't allow us to cancel this because those are different things, log base 10 of 3 to the power of something. But what we can do then is this exponent can come and be out in front here. Now since that thing has 2 terms in it, that exponent has 2 terms in it there, I'm going to have to use some brackets here and write 2 to the x plus 1 times log
of 3. And that's going to be equal to log of 600. Now, we've got it down to a point now where it's, even though it doesn't look like anything you've seen before, this is just a number and this is just a number. And on the left, you just have a number times a two-term thing. That's just the same as if you had something like, 7 times 2x plus 1. You can think about what you do there. Probably the 7 would be in front, right? And you'd just expand that. So that's what we're going to do here. We're going to expand this. So we're going to say log 3 times 2x and log 3 times 1 and write down what those are. Log 3 times 2x, I'm going to write it like this. 2x log 3. And then log 3 times 1 plus log 3 times 1 is just log 3. All right, so we have 2x log 3 plus log 3. And then we've got equal to log of 600 over here. Just like solving equations you've done in the past, you want to isolate the terms that have the variable. This term has the variable, so we're going to keep that on that side, and we're going to take this one and subtract it, move it. It'll end up over at the other side. So we're going to have 2x log 3 is going to be equal to log of 600 minus log of 3. And then our goal is to get this by itself. So we're going to divide both sides by 2 and by log 3. So what we need there is x is going to be equal to log of 600 minus log of 3 divided by 2 log 3. 2 and log 3 on the bottom there. That's our expression. This is our expression with base 10 logarithms. This is our expression with base 3 logarithms. You could do some simplifying here if you wanted to before you went to the calculator, if you want to make use of your logarithm laws. On the top, log 600 minus log 3 is actually log 200. You don't need to do this. You can always go to the calculator with the other part. And 2 log 3 is like log of 3 squared. And log of 3 squared is like log 9. If you want to, you can take that to the calculator. That's a lot easier to enter into the calculator than that more complicated expression. We will do that right now. So we'll work out the expression from our first solution method first here. So we had log base 3 of 600 and then subtract 1. Subtract 1 is outside of that logarithm, of course, and then divided by 2. It gives us that, 2.411 roughly. And then we'll work out our other one here. I'm going to use this fraction expression here again because it makes it significantly easier here. So I have log base 10 of 600. I'm going to subtract log of 3. And I have 2 log 3 there. You can put a multiplication in between there, 2 times log 3, but this is going to interpret it as multiplication anyways. You get that same value. As I said, you could put the simplified version there. This one I'll just do it this way, log of 200 divided by a log of 9, and you'll see, get the same thing there, roughly 2.411, all right? So for both of those, the approximate answer is 2.411. All right, let's do one more example. This third one is different than what we've done so far in a couple of ways here. First of all, the variable is in more than one place, and then that variable is involved in the exponent in 2 different exponential expressions with different bases. So we're not going to be able to use the sort of quicker method of just using the base that's involved to get rid of the exponential expression right away, because they're different, obviously. So we're going to use base 10 logarithms on this. And so we're going to start by saying we have 5 to the 2x, and we have that that's equal to 8 to the x plus 3. So if we take the log base 10 of both sides, you could use some other base, but it makes sense to use the base 10 because that's the simplest one and on everybody's calculator. At that stage, we're going to do what we did before, which is use the power rule to bring down those exponents. On the left, then, you're just going to have 2x log 5. And on the right, you're going to have that thing that has 2 terms in it, so I'm going to need to put it in brackets, x plus 3 log 8 Now we've turned it from an exponential equation where the variable is in the exponent into an equation that's like things you've seen before. These are just numbers. You just have some numbers times x, and we're going to work to get x isolated to see what it is. So that has to be expanded just like any other equation that has a number times that binomial like that. And so that's going to end up being x times log 8. We'll just write x log 8 plus 3 log 8, 3 times log 8 when you write that out, when you expand that. And on this side, we of course then have 2x log 5 still. Now, just like any other equation, we have 3 different terms here, 2 of which involve x and 1 of them that doesn't, and we want all of those on the same side. So if we subtract x log 8 from both sides, it's going to end up on the other side. So we're going to have 2x log 5 minus x log 8 on that side, and all we're going to have on the other side is 3 log 8. So this is just 2 terms that both involve x, and so we're going to try and put it into one term. Now we're going to think back to when you've solved equations that look like this before. Like let's say you had 7x take away 4x in an equation. You just mentally say 7 take away 4 is 3x. What you're doing is you're saying 7 take away 4, whatever that is, times x. Really what you're doing, if you think about it, is you're factoring out the x here, out of the expression. Right? 7x take away 4x, if you factor out the x, you get 7 take away 4. We can use the same strategy here and factor out the x out of our expression. If we factor out the x here, what we have left is 2 times log 5 minus log 8. And we have that this is equal to 3 log 8. Now we have x by itself right here, and so what we're going to do is divide by this big expression here on both sides, and that'll give us our solution. All right? So if we divide by that, we're going to get x is equal to 3 log 8 on top divided by 2 log 5 minus log of 8. That's that expression. That's what we can put into the calculator to see what it is. Now, we could actually simplify that if you want, right? You could make this into log of 8 cubed on top. You could make this into log of 5 squared, or 25. So it could be log of 25 minus log of 8. So this could be log of 25 over 8 if you want to do that first, and then put that in the calculator. But I'm just going to put it in as is there to see what this is. We'll do that right now. So we have 3 log 8 on top, and on the bottom we have 2 log 5 minus log 8. And so we got 5.475 if we round it off to 3 decimal places. So x is approximately equal to 5.475, right? At this point, I haven't mentioned this yet, but just like any other equation, you could take this number and check your solution by putting it back into the original equation and going to the calculator and saying 5 to the 2x, substitute the value in and see what it gives you, and then do the other side and just confirm that the two sides are equal there, all right? Let's do one last one here. All right, this one looks similar to what we just did in that there's the variable in more than one place. We have exponential expressions that have different bases. The only difference here is we have this wrinkle of this multiplied by 2 here. Now again, you might be tempted to say, boy, the 2 times 3, it'd really be nice to multiply that, give you 6, but 2 times 3 to the x is certainly not equal to 6 to the x. So let's not do that. This x only applies to that 3. But what you can do is you can still just do what we did before, which is take the logarithm of both sides, and it will all work out here. So I'm going to write it out. 2 times 3 to the x equals 5 to the x minus 1. If I take the logarithm of this side, I should actually put brackets around there because it's two things multiplied, and we want to make it clear it's logarithm of the whole thing. That whole side is logarithm of that side. Now, this is just a product in here, and we can deal with that because we know the logarithm of a product. We can just write that as logarithm of 2 plus logarithm of 3 to the x, because the logarithm of that product in there is like the sum of the two individual logarithms. And on the other side then, logarithm of 5 to the x minus 1. And now we can use the power rule and move that and that, those two exponents, to the front so that it's not an exponential equation anymore. Log 2 plus x log 3 equals x minus 1 log 5. We're going to expand this out like we did before so that we have x log 5 minus 1 times log 5 is just log 5. And on this side, log 2 plus x log 3. We want to gather all the terms that have the variable in it on the same side, that, and the other terms on the other side. I am going to choose to move this one this way and this one this way. It doesn't matter. I'm going to do it that way because this one's negative, and when I move it to the other side, it'll be positive. So I'll have fewer terms that are negative that way. So this side is going to be x log 5, the term that's already there, plus when this one moves, it's going to be minus x log 3. And then when this one moves to the other side, it's going to become plus. So I have the log 2 that's there plus log of 5. And those things are equal. I'm going to factor out this x like I did in the previous one. So I have log 5 minus log 3, and that's equal to this, log 2 plus log 5. And I can divide both sides by this to get the x by itself. So what I'm going to have here is x is equal to this stuff that's already here, log 5, and then divided by what's on the other side there, log 5 minus log of 3. Now again, we could simplify that down if we wanted to, right? You could make the top log of 10 if you wanted to, and you can make the bottom log of 5 divided by 3 if you want, and then punch that in the calculator, but we'll go and do it the way that it's written there right now. I'm going to put in this time without that fraction button. I'm just going to use the brackets here. If I'm going to do that thing on top, I need to put bracket log 2. I'm going to close the bracket because that's where my log 2 is. And I'm going to add log 5. Now, this is where I want to close this bracket because that's the end of everything that's on top. And then I'm going to put a division sign. And I'm going to put an open bracket here because I want to enclose everything on the bottom altogether, log 5 minus log of 3. That should give us our answer there. Now, as I said, we could have just worked it out as the simpler version there, log of 10. Log of 10 is actually 1, so if you wanted to, you could even do that, simplify the log 10. And then divided by log of 5 divided by 3. That should give you the same thing there because it's just a single term. All right, either way. Anyways, that was, x was roughly, if I remember correctly, 4.508 if we rounded it off to 3 decimal places. And again, you could take that number now and check it by substituting it into the original equation if you wanted to. All right, so there's several examples of how you can use logarithms to solve exponential equations.